Welcome to our first lesson in MCR3U. The course is called Functions, and our first unit is called Functions, and our first topic is functions. So I think you're getting the idea of how important the word function is here. Definition. So what is a function? This is a definition that you will need for a long time. A function is a relation in which for every x value there is one and only one y value. The way we can think of that visually is a vertical line test. So imagine a circle. You did circles in grade 10, a circle. Imagine what a circle looks like. If you drew a vertical line through a circle, let's see, here's a circle. Draw a vertical line through the circle somewhere. Is there any place you could draw a vertical line through the circle where it would cross twice? Of course. So that's not a function because it's failing the vertical line test. So is a circle a function? No, it's not a function. And what about a quadratic? Okay, a quadratic. Draw a parabola here, any kind of parabola, it doesn't matter. Can I draw a vertical line through that parabola somewhere where it will actually cross a parabola twice? So drawing one here, no, that only crosses once. Is there any place I could draw a vertical line where it would cross twice? There isn't, so that makes it a function. Because remember the definition is saying that for every x value, let's say the x value of -2, there is one and only one y value. Maybe this y value is a 7 here. So although we have the y value of 7 in two places, the x value, for every x value, there's only one spot. No matter what x value go along the x-axis here, back and forth, you pick any x value, you're only going to hit the parabola once. That makes it a function. What about a vertical line? A vertical line looks like this. Is a vertical line a function? No, it is not a function, because I draw a vertical line on top of a vertical line and it has an infinite number of points of intersection. What about the graph of a wave? And we will be graphing these later this year. So here's a wave. Well, if I drew that properly and then I drew a vertical line, it should only ever cross once, no matter where I graph that, no matter where I graph the vertical line. So the waves that we are going to do this year are functions. And a radical, this is a new one. A radical looks like this. So here's an x and y axis. A radical, I'll just draw one quick one here. It has a vertex somewhere like there, but then it only goes off in one direction, to the right or to the left. So let's say like this. It's kind of like half of a parabola. It's like a tipped over parabola, but we'll talk about them later. Is that a function? So the way I've drawn it, yeah, and we'll talk more about those later too. The next words we want to talk about, so the main word of course is the word function. That's very important for the entire course, as are these next two, domain and range, and I'm going to go over those in a minute. Domain means x, range means y. Set notation, I think I'll come back to that as well, because set notation is just what we use to write the domain and range. And a mapping diagram, I will give you an example of that as well. So these are all definitions you can come back to read later. We're going to do some examples that incorporate those, and also there's more definitions in your textbook if you need them. All right, my first example is to graph using the slope y-intercept method, y equals -3x plus 4. So that is a grade 9 question, a line. You did lots of these in grade 9. When we learned about the form y equals mx plus b, and remember that m is your slope and b is your y-intercept. Okay, so before I graph it, I need to put a scale on my axes. If you don't, tell me your scale, tell me what you're counting by, then I will guess. So for this one here, I'm going to count by ones. Every grid line is equal to 1 unit. I'm going to label every second one though, just because it gets really crowded if I label every one. So I'm just going to label every second one. Now, sometimes people will just do that and they'll stop there. And they'll say, okay, all right, label it, it's done. All you've labeled is one portion of it. So that means I get to guess what you're going to do on your y-axis, right? And what I will often do on tests is say, oh, you didn't label your y-axis, so I'm going to guess you're counting by sevens. Oh, are you counting by sevens? Well, then your graph's totally wrong. Everything gets a 0. So don't leave it up to me to decide what your scale is, because you are not going to like what I pick. You need to label it all yourself. If I want to count by ones again, fine, but then I've got to label it so that your teacher doesn't just decide for herself. Now here's another error if you leave it like this and you haven't labeled the other half of your axes, because maybe your graph is, most of it's occurring in this quadrant right here, and you think, well, I'm not going to label anything else. Well, that's like in English class writing half of a sentence and just letting the reader decide how to finish it. You will lose 4 marks again. So a big part, this is university level math now, a big part of this course is lost. Marks are lost by not doing these little things here that are so important. And if you get in the habit of doing them now, you're going to save yourself a lot of agony later for losing the marks when you're maybe applying to universities and you're losing all kinds of half marks all over the place. So we've labeled our axes. Now we're going to graph that line, and I will use light blue for that. The first step in graphing, step 1, is to place the y-intercept. Now there's lots of ways to graph lines, and you learned it in grade 9, but I'm just going to review this one method. I'm going to first start by placing the y-intercept. Now my y-intercept is a 4, so I'm going up the y-axis and I'm putting a dot on the 4. That's my y-intercept right there. The second step after you've placed your y-intercept is to count out the slope from the y-intercept. Count out the slope from your b value, wherever your b value was, from the b value. So that means I'm going to go over to my graph, and I'm going to, my slope, I'm right here, my slope is -3. That's -3 over an invisible 1, right? That's -3 over 1. So when we're talking about rise over run, this is always a run, and we always run to the right. The top would be my rise, but since it's a negative, it's actually a fall. It's not a rise. So from my 4, I'm going to fall 3 units. So 1, 2, 3 units, and then I'm going to run 1 to the right, and that leaves me with putting a dot right here. And I can do all that again, just to make sure I get a straight line here. I'm going to fall 3, 1, 2, 3, and I'm going to run 1 and put another dot here. So now I'm just going to erase those little purple marks that I put in there, and I'm going to get my ruler, and you must use a ruler, and I'm going to get my ruler and I'm going to connect those 3 dots right there. So I'm using a tablet here, and my tablet with a ruler is very glitchy. It makes it hard to, you should be passing directly through those 3 points, but I just spent several minutes trying to do it, erase it, do it, erase it, and it wasn't working out. This is the best I can do with my tablet. Okay, I just put arrows on the end. The arrows are there because this line continues on to infinity. So let's say I had just decided to sub in a point here for x. Let's say I wanted to say x is 10. So I have 10 for an x value. When I sub in a 10, I then get, this is going to be a -30 plus 4. So my coordinate will be, x will be a 10 if I sub in a 10. -30 plus 4 is -26. So that's a coordinate. Now I'm going to go way over to my graph. I couldn't fit it on. 10 -26 would be way down here in the corner. So this is definitely a coordinate on my line, 10 -26, but I'm not going to graph it. But putting the arrows on the ends of my line indicate that I understand that this line continues on to infinity, that there are an infinite number of points on this line that I'm not graphing on both ends. If you don't put the arrows, sometimes people just go from one dot to a dot and just draw that little segment. That's a line segment, it's not a line. And again, you'll lose marks for that. These lines continue on to infinity. They have to have arrows on the end to show that. So let me erase this stuff at the bottom. So there's our line. Our line is y equals, let me label the line. Y equals negative 3x plus 4. Part B says graph by placing the vertex first. Okay, where's the vertex? Remember? Vertex comes from these two numbers right here. The vertex is, so this is grade 10 now. What makes this bracket equal to 0? What makes that bracket equal to 0? That's your x value of your vertex. So in that case, that would be a 4. And then this entire last value here is a negative 6. So that's my vertex, 4, negative 6. So I'm going to place that 4, negative 6. Okay. So that's step 1. And it says that they're placing the vertex first. So place the vertex. That's our step 1. Place the vertex. Step 2 is much harder. Step 2 is graphing with the a value. So our a value is a 2. That means we would have a vertical stretch by a factor of 2. So a vertical stretch of what? Well, our basic parabola, y equals x squared, looks like, let's say like this, okay? That's y equals x squared. So a value of 2 on that is going to stretch it. So how do I get those coordinates? Now you already learned how to graph. You spent a lot of time in grade 10 graphing quadratics. So you already have a method. I'm going to show you a method here. You don't need to use this method. You already know this because you already, well, you should have had about 75 or higher in grade 10 academic. So you're good at this already. You know how to graph quadratics, but I'll give you a bit of a recap here. So my a value is a 2. Let's talk first about this one here, our parent graph. If I had that graph and I was graphing it, this is what I would do. This is one way I teach it. I would go to the vertex, and then I would go over 1 unit to the right and 1 unit up, and I would put a dot there. And I would do that in both directions because of symmetry. 1 unit to the left and 1 unit up, and I would put a dot there. So if I was just graphing x squared, or with the vertex, but x, no a value, I would be doing this. And then I would go for my vertex, then the next thing I would go over 2 units to the right, 2 units, and then I would go up 4 units here. Oops. Up 4. 1, 2, 3, 4. I would have a dot right there, and the same thing on the other side. And so my parabola would be looking like this. Oh, I'm going to erase that. So that would be if I just had the basic parabola, which I don't. I have an a value of 2, so I can't graph it like that. Now you might have learned a step pattern to graph last year. So what I'm going to do is from my vertex, so always starting at the vertex, I'm going to do the same thing I was just talking about. I'm going to go over 1, in both directions. I'm going to go 1, and then in a minute I'll go 1 to the left. So I first go over 1 unit. Then the next part is up. And I'm going to, normally I would go up 1 right here. But we have an a value of 2, so we're not going up 1. We have to take that number that was a 1 and we have to multiply it by the a value by 2. So I'm actually going up 2. So up 1, 2, and here is my next dot. And I do the same thing on the other side. Over 1 and up 2. There's my next dot. Let's try that again. I'm going to go back to the vertex. So start at the vertex. And if I didn't have an a value, or the a value was an invisible one, if that was all I had, I would normally, from my vertex, I would go over 2, and then I would go up 4. That's what I would do if my a value was 1. But this piece has to change. I can't go up 4. I take that 4, I multiply it by my a value. So I'm really going to go up 8. So instead of over 2 and up 4, I'm going over 2. Let me put it in another color here. I'm going to go over 2, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Here we go. Same thing on the other side. Over 2 and up 8 will take me to here. I'm just going to put those in red. So I've got 5 dots on there, and that's all I need for a parabola. 5 is plenty. If you, as I was doing that, if you thought, what is she doing? That is so confusing. That's because you learned it a different way, and you don't have to do it the way I just showed you how to do it. You can go back through your grade 10 notes if you need a recap. I'm not teaching you how to graph parabolas in grade 11. You're expected to know that already. So again, you would have had a good mark coming out of grade 10. Quadratics was a big piece of grade 10 academic math. You already know this. So if you're confused right now, just ignore the way I was showing you and do the way your teacher showed you last year. But again, this is already knowledge you have. This is not new, right? The new thing we've done today was those definitions so far. That's it. Nothing else is new. So I'm going to turn these into a nice smooth curve. This is curved. Remember, it is not lines. And arrows at the top because, of course, my quadratic, my parabola is continuing on to infinity. Whoops, I curved over there a bit. Let me fix that. Try that again. Let me write the equation here. 2 times x minus 4 squared plus 6. Okay. So there is just some grade 9 and 10 review there of graphing a line and graphing a quadratic. What kinds of relations are these? I just said the answers to that actually. The first one is, the first one that we did is a linear relation. Linear relation. And the second one that we graphed is called a quadratic relation. Or relationship, right? That's what the point is, the relationship between x and y. So are these relations functions? Think back to the definition I gave you before of the vertical line test. Imagine drawing a vertical line through them. How many times would they cross? So let's look at the line first, the blue line. If I drew a vertical line anywhere through this blue line, it's only going to cross once. So this is definitely a function. And all lines except for a vertical line, which is a rare case, but really all the lines you're ever going to graph this year in y equals mx plus b form, they're all functions. All the quadratics we're going to graph this year are all functions. So the two main types of relations you know from grade 9 and grade 10 are both functions. So we're building on those this year. Are these relations functions? Yes, they are. Part E, this is the first new thing on example 1. State the domain and range for both relations using proper mathematical notation. Domain means all of the x's and range means all of the y's. And what do you mean? What are all, like, whoops, y's, not y2, y's. So what is that supposed to mean? Domain, I'm going to talk about the line first. The domain of the line means when I look up to my original equation, remember in green there I substituted in a 10, right? Is there anything I couldn't have substituted in for x? Could I have not substituted in a fraction? For example, if I substituted in a fraction, would this not work? Could I not figure it out? Would there be a problem? No. I could sub in whatever number I want for x. Any x value is fair game. I could sub in any decimal, any fraction, any positive, any negative number. I could sub in anything I want for x, any number at all. That means my domain, the x's, all x's are within the set, within the domain. The way we write that is, so I'll stick with light blue because that's what I did the line in. So for the line, and for all lines, the x's, so you have to do a curly bracket. Let me do a better one than that. Do a curly bracket. The x's we're allowed to use. We write that x is an element of, that's element of, it's kind of like an E. And then we do a capital R, and we usually put another bar in it just to show that it's a number set. X is an element of real numbers. Real numbers are decimals, fractions, everything, positive, negative. I could use any x value I want to sub into that line, and I will get an answer. for example, if I had, let's say I had an equation y equals the square root of x, I can't use any number I want there. I can't put in a -4. So all x's aren't in play in that case. But in the line, all the x's are. So x is an element of real numbers because I can use whatever number I want. There's no restrictions at all. Now let's look at the parabola, talk about the domain of the parabola. Put that over here. Sorry, I should put a D in front of this for domain. So now let's talk about the quadratic. The quadratic, for its domain. So same thing, let's look back up at the equation I had originally. Let me erase some of this stuff around it here. So looking at this equation, is there any value for x that I'm not allowed to use? Can I use a negative, a positive, a fraction, a decimal? Yeah, I can use whatever x value I want. And what that means on the graph is, if I subbed in a 10, remember we had a number way down here for 10, I could sub in 100, I could sub in 1,000,000. Now I don't want to graph those numbers because my line would be way up to the sky if I did that. But I could use the x value of -1,000 and sub it in, and then I get a number really high up here. But all of these x values, I could sub in any x value here that I want, and I would get an answer. I would get an output, right? So if this is my input here, any of these x values, any of them are good. Any x works. So the domain for this quadratic is the same as it was for the line. We have no restrictions. X is just an element of real numbers. X can be any number we want. We can sub in and we will get an answer. So that's what the domain is. Now let's talk about the range. Range, as I wrote, are the y's. So look at the graph for the blue line first. When we look at the graph for the blue line, imagine it continuing on to infinity. Will it go will it continue, or is it going to stop somewhere? Is it going to stop at y equals 20 and that's as far as the line goes? No. It's going to continue on. It's going to continue going up to infinity. So all the y values, all these y values are going to be used, and it's going to continue going down, 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 down. It's never going to stop. It's going to go down to -infinity. So the range means from top to bottom. How high does it go? How low does it go? That's what the range means. How high, how low. And in this case, the line has an unlimited range, right? The range of the line is the same like the domain, except y is the range. All of the y's will be used. If I could graph that line to infinity, I would end up passing by or cutting through every y. So right here, I kind of stopped it at about, say, 7.3. But the y value of 8 would be used if I continue to graph. The y value of 9, 10, 11, 12. All y values, all decimals, all fractions, from -infinity to +infinity. Not so for the quadratic. So for the quadratic, this is going to go up, right? It's going to continue going up, 6, 7, 8, 9, 10. The range is going to be up, up, up. The range is not going to stop. The parabola is not going to stop somewhere. It's not going to hit a wall and all of a sudden not go any further. But it's not going to go below -6. Quadratics do not turn around and come back down again. So this range does have a restriction. For example, look at this -8. The parabola does not exist across here, -8. It's not going to come around here and then, oh, there's my -8 value over there. No, it is not going to exist. So my range for the quadratic, so this is the first one we've had where it's not just real numbers, the range. So we start off saying that y is an element of real numbers. That means we're using decimals, fractions, positives, negatives. So it's like this, but, so I put this line in here, it's like my but or exception, just a straight line. What we actually say for that is such that. So y is all real numbers, and you can think of that as but. All of the y's we're using are going to be from -6 and above, so I write all of the y values are greater than or equal to -6. That's the range. So this range does have a restriction, and all parabolas do, all quadratics do, because they have a vertex, and it either opens up or it opens down. So it goes to infinity in one direction, but not in both directions like the line does. That is really important, what I just wrote down. So I would, and what I explained, I didn't write down everything that I said. So I would suggest you press pause right here and make some good notes for yourself about domain and range. Example 2. Consider this relation. Now this time we don't have, last time I gave you an equation of a line, and that was fine. I gave you an equation of quadratic, but this time it's just a set of ordered pairs. These are just coordinates. So I don't know what shape it is. I just have some coordinates. So let's put them into a scatter plot. This is called H. Let's put H into a scatter plot. We're not going to connect the dots because we don't know what's going on in between all the dots. So let's just put the points on. I'm going to use purple. So before I put anything on, let's say I just started here 2, 0, right? Well, if I didn't put a scale on there, and then a teacher went to mark it and said, well, what's that coordinate? I think you're counting by tens, so I think that coordinate is 20, 0. Oh, I guess it's wrong. Everything's wrong. So if without a scale, then you're letting your teacher decide what your scale is, and they may not choose what you're hoping for. So let's get a scale on there. I see that I'm going to look at all the numbers in the list here, and my largest X number is a 5, so I only need to get up to 5 here. I think I can fit that all on 2, just barely, 3, 4, 5, and that's my X-axis. There's my y-axis up there. My y values aren't even that big, so 1, 2, 3, 4, and the negatives. So again, don't stop. Don't just label part of your axes and not finish it. And you can change your scale from X to Y, but what I can't do right here is I can't put -2, -4. I can't count by 2's here when I only counted by 1's here. It has to be the same on that one axis. So I can't change it. So this one is going to have to, I'm going to still count by 1's. -1, -2, -3, -4. Now, let's put all of our points on. So you can press pause and do that. I'm going to press pause and do that. When you come back in 1 second, they will all be done. There's my purple dots. And part B says, state the domain in numeric order. Your textbook doesn't put in order, but it's supposed to, low to high. So my domain, I'm going to start with a D, talking about my domain. Open a bracket. So domain, remember, those are all my X values. So what are all the X values in order? So when you look at the coordinates up here, I'm just labeling the first one. The first is an X, the second is a Y. So what's my smallest X? I always have to label domain and range from low to high. So my low value is a -1. That's the first X value in my domain. Notice I'm not starting with X as an element of real numbers. I don't know that. So real numbers includes decimals, fractions, positive, negative. I don't have any of that. So I don't know that it's using all the real numbers. So I can't say that it is. So I'm just going to list the numbers I have. And you can, even if you want to, your domain, we already put a D there, but we can also just put an X here if you want to, just to remind yourself we're looking at X's. Okay, you can do that if you want to. So my lowest one again is a -1. What's the next lowest value? X value, a 0. Next lowest value is a 2, and that's in there twice, but that's okay. I'm just going to write it once in my list, and then 5. That's my domain. My domain is just those numbers, that's all. Part C says state the range. Okay, again, low to high. Range, you can put a Y if you want to remind you that the range is the Y values. My lowest Y value, looking at my list here, this is my lowest Y value. That's a -4. What's the next lowest Y value? That would be the -2. Next lowest Y value is a 0, and then the, yep, we've got 0 there twice, that's okay. And the highest Y value is a 2. So even though your textbook doesn't always put them low to high, you have to. You have to on a test, you have to on a quiz, so you have to. There's the range. So that's how we list domain and range when we just have a few points in a scatter plot. That's all we can do. Now, is H a function? Explain. The first question in your homework is just like this. It's just like this example we're doing right here. Is it a function? So remember what a function means. A function is for every x value that we have, these are our x values, there's only one y value. Visually, a vertical line test. So I could draw a vertical line right through this point here, and it would only cross this point once. If I drew a vertical line, it would just cross once. That would part's a function. But is there anywhere on here where I could draw a vertical line and it would cross twice? Because if that happens, even once, if it happens, then I don't have a function. And it does. When x is 2, right here, if I drew a vertical line right through x equals 2, it hits twice. I have 2 values. So is h a function? No, it's not a function because the x value of 2 is used twice. The x value of 2 is used twice. And remember the rule for every x value, there is one and only one y value. Well, for the x value of 2, we've got 2, 0. Then we've also got 2, negative 2. So for every x value, we don't have one and only one y value. We have 2 y values. So it's not a function. The last thing for E says set up the relation H into a mapping diagram. And again, if you go back to the front of your page, you'll see a definition for mapping diagram. And what it is 2 ovals. I'm just going to draw 2 ovals here. Mapping diagrams are kind of weird things, but they're also x is domain, y is range. We have another way to talk about x and y here. So we have 2 ovals like this, and we have the numbers, or sometimes words, but most of the time it's numbers, listed inside the 2 ovals. So these are going to be our x numbers are going to go in the first oval, and our y ovals are going to go, our y numbers are going to go in the second oval. And we're going to put them in the order that we had for the domain and range, low to high. So my x's, again, were -1, 0, 2, and 5. My y values, -4, -2, 0, 2. So what the mapping diagram does is we have arrows connecting the x values to the y values. So my x value of -1, let's look up at my list of coordinates. See this last one here, -1, 2. -1 is x, 2 is y. So I'm going to go from -1 and I'm going to draw a line to the 2. So the mapping diagram is just saying that's the pair that's connected. That's all we do. So my 0, so you're going to look for the 0 coordinate here. Just erase this stuff here. The 0 coordinate, the 0 x value is here. So I'm going to draw a line from 0 to -4. That's it. So just keep doing that for the other coordinates. See if you can do that without me having to explain it again. And then when you're going to press pause here, and I will have the answers up here in 1 second. And there's your second up. So there is my mapping diagram all done. So you can look at a mapping diagram to tell if a function, if a relation is a function or not. If when you look at the mapping diagram, you see duplicate values for the x. So here my x value of 2, I've got 2 lines. I've got a yellow line and a red line, both coming from the 2. So remember the value of 2 is used twice. That's how I know it's not a function. So if you have a mapping diagram and you have a number on the x side that's going to 2 different places, then it's not a function. It's okay to have like 0. We've got 0 in 2 different spots. That's okay. And if you look at the graph, you've got 2, 0 and 5, 0. It's okay to have y values repeated, and a parabola has that all the time, right? A parabola would go like this. We have duplicate y values all the time with a parabola, but we shouldn't have duplicate x values. So that's how a mapping diagram will help you to see if a relation is a function or not. And the last thing here, important concepts, an independent variable. This is back to grade 9, something that exists on its own, unaffected by anything else. Time is a common example of an independent variable. A dependent variable is one that is affected by the independent variable. Amount paid. How much money you got paid would depend on how long you worked, would depend on the time. Independent variable is X, dependent variable is Y. So the independent variable is domain, because remember domain is X, and dependent variable is range, because range is Y. And you have one question in your homework that refers to this distinction. So there is your first lesson in grade 11 university math level. Rewatch anything that you need to, do the homework questions, use your notes that you just made to help you answer all of the questions in homework, and let me know if you need any help. Good luck.